Okay, so problem, we're going to start with doing chapter 10, problem number 83, which asks us, what is the torque about the origin of the force? They give you this big equation. If it is applied at the point whose position is R, and then they give you an equation for R. So we have problem 83, a force that's equal to 5.0 I hat minus 2.0 J hat plus 1.0 K hat, and that's going to be in newtons. Okay, so this is some force, right? I means we're going in the x direction, J is in the negative y direction, and then K is coming out of the board towards you. So that's our force, and we also have a position where we're applying that force. That position, they tell us, is negative 2.0 I hat plus 4.0 J hat. And they tell you right away that that's given in meters. So that's nice because this tells us that everything's an SI system. So we don't have to worry about units, don't have to do any kind of funky conversions or anything. Okay, and then I'm asked to find the torque. And I did say torque, not twerk. They're different, though they're actually kind of the same. Twerking is torquing. Torque. What's the equation for torque? There's a bunch of them.
R times force.
R, and not just times force, cross force. R cross F. That's torque. It's a cross product. So we have to go back to that math thing that we did with cross products to find the torque. So to do that, torque equals R. So we write our R vector first, 2.0 in the I hat, plus 4.0 in the J hat. And we cross that into the force, which is 5.0 I hat minus 2.0 J hat plus 1.0 K hat. Okay. Everybody following so far? So far, all I've done is I've just taken the equation for torque and I've plugged in these equations. I've plugged in their values. Okay, so I need to go from here. Where do I go from here? I start distributing in the numbers, and I leave the cross products of the letters to figure those out at a later time. So I'm going to take this 2.0 I hat, and I'm going to distribute it into each part of the second part of this multiplication. So this is algebra. So I have a new negative 2.0.
Sorry.
No problem. And I need to multiply that by 5.0.
Just came from the library and all that.
No problem. You're all good. And then I need to do I hat cross I hat. Right? I multiply the 2 and the 5. Just straight up multiply those. And then I have I cross I. The directions is where you need to do the funky stuff with the right-hand rule. Okay. And then I need to add negative 2.0 again times the second element in that force, negative 2.0. And then what vectors am I taking the cross product? What vector comes first? I have an I hat. And then what vector comes second?
J.
Cross J hat. And the order of those is important. You have to maintain that order. Okay. And then we do adding negative 2.0 times 1.0. And we'll do an I hat cross K hat. Okay. So that has taken care of this negative 2.0 I hat and distributed into all of those others in the other elements of the force. I need to do the same thing with the J hat. So I have plus 4.0 times the 5.0. And what's my cross product? I multiplied the numbers. What are the letters that I'm multiplying now?
Oh, J and J, that cancels, right?
J hat and I hat. Then plus 4.0. Distribute it right here into that negative 2 times the negative 2.0. Then here's the J hat cross J hat. And then plus 4.0. Multiply that by the 1.0. And I have my J hat cross K hat. I really do recommend writing these out. You can take shortcuts, you can multiply stuff, and you can try to write it all in one line. You can try to do it all taking up less paper. You'll make fewer mistakes if you just write the whole thing out. Step by step. So torque. Now I can multiply the numbers. Negative 2 times 5. What's negative 2 times 5?
10.
Negative 10. I hat cross I hat. 0. Negative 2 times negative 2.
4.
It's positive 4. And then I cross J. This is where you take your right hand.
K.
I take my right hand. It is K. And I point my fingers in the direction of I. I rotate my wrist around so that I can bend them into the direction of J. So how do I rotate my wrist? We're looking at, this is I hat going this way. I need to bend my fingers so that they're pointing up. If I bend them now, what direction are they going?
Down.
That'll be negative J. So what do I need to do to my wrist? What do I do? Talk loud.
Flip.
Flip it. Okay, so now I'm ready to shoot my webs, right? I'm dressed up as Spider-Man. Happy Halloween. Here we go. Here we go. We'll go full Spider-Man. So I bend my fingers. They're pointing up. What direction is my thumb going? Out. And what direction is out? That's K hat. So we have I cross J gives me K hat. Okay. Plus negative 2 times 1 gives me negative 2.0. And then I need to do I hat cross K hat. So let's do that. I hat. I need to bend my finger. What's K hat direction? That would be out towards you. So I need to bend my fingers so that they're coming towards you. And then what direction is my thumb going? Down. Negative J. Okay, so that takes care of those top three. And then 4 times 5 is 20. J hat cross I hat. Let's see. J hat cross I hat. That gives me negative K hat. Plus 4 times 2 is negative 8. J hat cross J hat. 0, big fat goose egg. Plus 4 times 1 is 4. And J cross K. Let's see. J cross K gives me I hat. This exam is going to be the most fun one for me to watch you all taking, because you'll be sitting there and doing all kinds of stuff. Then there's the one student that I'll feel really bad for, because you'll be using your left hand and all of your answers will be wrong. Yeah.
What was the written out version of what you just did with your hand?
The written out thing. So let's do the written out thing and check all of these. So I can do so I just write out the alphabet, or write out the alphabet in reverse. So here's the little guide. And what you're doing is you're stepping one at a time to get to the next one. So if I need to do, well, this doesn't work for I cross I. For cross products, you just need to know cross product in the same direction gives you 0.
Okay.
right? I cross I gives me 0. For I cross j, I come down here and I look at I, and I look at what's directly next to it in the direction that the arrow's pointing, and j comes next. So I can use this top one to find I cross j gives me k. So there we go. I wouldn't use the bottom one, because if I come to the bottom one and I go to I look next to I, and k comes after k, I, so I can't use the bottom one to figure that out. Does that make sense? So then next, I cross k. So I come here, I look at I, the next one is j. So I can't use the top. I come down to the bottom, I look at I, next one is k, then after that is j. Because I'm using the bottom one, it's a negative. Alphabet's going opposite direction. That's a negative j hat. So negative j hat. Okay? Any questions on that? Yeah.
Another form is like the clock, right?
Yep, so you can do it like a clock. There are so many different ways you can do this. If you like the clock. Going clockwise, you'd be positive. Going counterclockwise, you'd be negative. And then I've got some 3D prints going right now with some little arrow things that can help you figure this out too. They should be done at some point during class. So once they're done, I'll come by and show everybody at your tables individually how to use those. Okay, so lots of different ways to do the cross product. So I've got this torque. I can cancel out everything that has a 0 that goes along with it. Right? All those things with zeros go away because you're multiplying by 0. And then I can simplify this. Torque equals 4.0 k hat. Negative 2 times negative j gives me a positive 2 j hat. And plus a negative 20 k hat. And then plus a 4.0 I hat. And then if we want to be really nice and pretty with it, we typically write I hat first, so we'd have 4.0 I hat. And then we'd have plus 2.0 j hat. And then I would do negative 20 plus 4 gives me negative 16. So this would be a plus a negative 16.0 k hat. And this would be the final answer. Checking the answers, making sure I got it right. Check. That's exactly what the answers say. Something else to point out. Do you have to put it in this simplified form on an exam? Right? You're kind of pressed for time on exams. So if I gave you something like this on an exam, can you leave it just... Well, first, can you leave it like this? No, you will lose points, right? Because that doesn't show that you know how to do the cross product. Can you leave it like this?
Yeah.
Sure. That's fine. You don't have to simplify it all the way. I'm not a complete monster. Okay. Any questions on this one? This is number, again, 83. ¿Estás bien? Gracias. I took 2 years of Spanish in college. And I'm still horrible at it. Okay, next question that I want to do. I want to do problem number 117. This is a different type of torque problem. This one comes with a very exciting demonstration. Number 117, you have 2 children push on opposite sides of a door during play. I don't know why they write it like that. 2 kids are playing. Okay. Both push horizontally and perpendicular to the door. One child pushes with a force of 17.5 newtons at a distance of 0.6 meters from the hinges, and the second child pushes at a distance of 0.45 meters. What force must the second child exert to keep the door from moving and assume friction is negligible? Okay, what does this look like? Let's draw a door. So there's a hinge, and then here's the actual door. So we are looking at an overhead view of this door. And we have two kids. One kid up here and one kid down here. One of the kids is pushing with a force of 17.5 newtons at a distance of 0.6 meters from the hinges. So this kid is pushing at 0.6 meters away. He's pushing with some force. We'll call that force 1 at radius 1, and force 1 is going to be equal to 17.5 newtons. So he's pushing the door that way. And then we've got the second kid at a radius R2, bless you, and R2 is 0.45 meters. And they asked us to find F2. There is a certain amount of torque that you need to open this door. And it's the same no matter what. Torque from kid 1 has to be equal to torque from kid 2 if you want this door to not move. Now, if these kids are siblings, this isn't a very realistic situation because the bigger sibling will definitely slam this door right into the face of the smaller sibling. Any of you have siblings?
Yes.
Yeah.
Your siblings do this to you?
No, I'm the older one.
Yeah,
Yeah.
mine do. Mine are bigger than me, so they pick on me. But now I can build robots so I can fight back. They can't beat a robot. Okay, so torque 1 has to be equal to torque 2. So R1 times F1 has to be equal to R2 times F2. I want to know the force that the other kid has to apply, so I can solve this all for force 2. Divide both sides by radius 2, and I will get R2 canceling, and force 2 is R1 times F1 divided by R2. I can plug in my numbers. R1 is 0.6. F1 is 17.5. Divided by R2 is 0.45. And F2, when you plug all those things in, let's see what we can get. Bust out my fancy $5 calculator. This is what I got. Okay, so when you plug it into your calculator, you should get 23.3. Let's make sure we did it right. Let's look at the solutions. Yes, 23.3. Good. Fair game for an exam. If you'd like, I could talk to Dr. Jaber and insist that she puts this on the organic chemistry exam. Huh? Why? This is easier. This is probably much easier than organic chemistry.
It is.
Organic chemistry, awful. I never took it.
I'm done with it.
Students are insisting, like, comment, subscribe, and mash that bell so you get notified whenever I make a new video.